solving equations with decimals, you're going to see that this is done the exact same way as what you did of solving equations with integers. Your ultimate goal is still, with any equation, to isolate the variable. Remember, we're trying to get the variable on one side of the equal sign by itself. How do we do that? We undo what's happening to the variable. Addition and subtraction undo each other. Multiplication and division undo each other. And yes, I want you to write this again. The reason is because if you write this multiple times, you're going to remember it. You should be able to quote this slide for me by the end of the unit. Here's some examples. M minus 3.84 equals 7.2. We want to isolate the variable. We're going to undo what's happening to the variable. It's being subtracted by 3.84. So we're going to undo that by adding 3.84 to both sides. That's a bad marker. Let's get a different one. So I've done that on the left side. When I go to the other side, I have to remember my decimal rules. I'm adding, which means I need to line up the decimals. That cancels on the left side. These are additive inverses of each other. They're just going to come up to be 0. So M comes down. Then I'm going to add 7.2 plus 3.84. If you want, you can annex a 0 here so that you have the same number of digits. 0 plus 4 is 4. 2 plus 8 is 10. Line up my decimal, carry the 1. 1 plus 7 is 8. 8 plus 3 is 11. You can also check these, put it back into the equation. This is going to be more work because of the whole decimal thing, and subtracting 11.04 minus 3.84 in your head is not going to come very naturally to you. However, you can estimate to see if it makes sense. Is 11 minus almost 4? That's going to be somewhere close to 7. That makes sense. That will catch mistakes as if you, let's say you subtracted instead of adding on both sides and you got like something like 3.4-ish, 3.3 something, and you substitute that back in. 3 point something minus 3 point something is going to be close to 0, not 7. So still check it in your head, but you're going to be estimating. You're going to be rounding those decimals to numbers that are easier to work with in your head, and that way you can still catch those errors. Coming over to the next one. 4 equals 1.6c. You're going to undo what's happening here. When the number is right beside the variable, that means you're multiplying. You undo multiplying by dividing. So we're going to divide by 1.6 on both sides. So C is going to equal, and then I'm going to divide this out. You probably want to come over to the side to set up your long division. You're going to do 4 divided by 1.6. 1.6 has to become a whole number, so I move the decimal over. Okay. 16 will go into 40 2 times. That's 32. Subtract, you get 8. Bring down another 0. 16 will go into 80 5 times. 5 times 6 is 30. Carry 3. 5 times 1 is 5 plus a 3 I carried is 8. So C equals, I'm going to bring this down here. C equals 2.5. If you'll notice in the original equation, the variable was on the right side, and that can be kind of confusing for students. It still is kind of confusing for me as a teacher. I am much more comfortable when the variable is on the left side of the equal sign, and you'll see how I reordered it. Instead of writing 2.5 equals C, I swapped it around so that C equals 2.5. It doesn't matter which way you have it because it's still going to show that those two things are equivalent. Again, check that in your head. Put 2.5 into here. 1.6 times 2.5, you can round those. Let's say I round this one up to 2, and that goes up to 3. That would have been 2 times 3 is 6, or if I rounded that down to 2, 2 times 2 is 4, so that makes sense. practice these and then we'll compare our answers. Okay, with practice A, that was 20.51 plus y equals 26. We're going to undo adding by subtracting 20.51 on both sides. It cancels over here on the left. Y comes down, and I have 26 minus 20.51. You can see where I lined up the decimals. I annexed a couple of zeros. And if you notice when I subtracted these, you didn't see me like marking out zeros and putting tens and nines and borrowing and all that business. Confession, it kind of stresses me out a little bit. I would always get confused as a student, like, okay, is that a 10, is it a 9, when I had a bunch of zeros that I was borrowing from. So what my brain does is I count back. It's like I was counting back change if I was working at a retail place. I think, how much do I need to add to 51 to get to the next dollar? Well, I need to add 49 cents. This is close to 50, it's one more, so this is going to be one less than 50. So to do that, this would have went down to 25. 5 minus 0 is 5. And then 2 minus 2 is 0. And I kind of check it in my head. If I were to combine the 51 and the 49, that's going to become 1. That would be 21, and then the 5 would make it 26. If that was too confusing for you, then just do it the way that your second grade teacher taught you about borrowing. But like I said, I never really liked all that borrowing stuff, so I found a way around it. Check this in your head. Does it make sense? About 20 and a half plus about 5 and a half. It makes sense that that would equal 26. We subbed it back into the equation. We checked to make sure it made sense. Coming over to practice B. W over 3.9, which we know means dividing, equals 1.2. I'm going to undo dividing by multiplying by 3.9 on both sides. And you saw where I came down here and I multiplied, and I got 4.68. And estimating these, that makes sense that 1 times about 4 would be about 4. You can sub it back into the equation to check it. Let's round this up to 5 and round that up to 4. 5 divided by 4 is going to be 1 with some stuff left over. So that makes sense. Our solution then is W equals 4.68.